For example 2a, we're going to determine whether our function is even, odd, or neither. And if a function has symmetry with respect to the y-axis, then we call it even. And if our function has symmetry with respect to the origin, then we call it odd. Now notice that when we were working with equations in example 1, we also tested for x-axis symmetry, but if we're working with functions specifically, then we do not test for x-axis symmetry. And then you can see up here the reason why, that if you draw a graph that is symmetric with respect to the x-axis, just kind of pretend that that's a nice even graph, then it fails the vertical line test and it is not a function. So functions will never have x-axis symmetry because x-axis symmetry does not pass the vertical line test. And then before we get going on the actual work in the example, I want to just say that except for f of x equal to 0, your function cannot be both even and odd. It can be one or the other or neither. So let's go ahead and do example 2. If I am testing whether or not my function is even, it is going to have y-axis symmetry, which means we are going to replace all of our x's with a negative x. And when I write down my function, I'm going to replace my f of x with a y, and then I write y equals 5x to the 7th minus 6x cubed minus 2x, and let's go ahead and substitute in our x's with a negative x, or replace our x's with a negative x. Make sure you're using parentheses, and then let's clean everything up. Now I have negative x to the 7th, and I'm going to actually show that up here. Negative x to the 7th has 7 negative x's in a row. That's 2, that's 3, that's 4, 5, 6, and then one more here on the end, 7. For every 2 negative x's that multiply together, you're going to end up with a positive result. So as I group these up in 2's and multiply each set together, I get a positive. And then finally at the very end, I have this extra little negative x that does not have a partner, so he still maintains his negativeness, and you end up with a positive times a positive times a positive times a negative, and the overall result of the term is negative. And that's going to happen every single time you have an odd exponent, that x term is going to be negative. So when I look at my negative x to the 7th, the overall result is negative x to the 7th, which actually would look like this. And then that negative x to the 7th times positive 5 is going to give me an overall result of negative 5x to the 7th. The whole term is going to be negative, and then we just are going to write that negative out front of the term. So it's negative 5x to the 7th. And then negative x cubed is going to have an overall result of negative x cubed times negative 6 will give me a positive term. So that's positive 6 cubed. And then at the end here we have a negative times negative, which is a positive. And I do have my first term matching already in sign, so I'm not going to try to flip the entire function by dividing through by a negative. So we're ready to compare. And as I look at my new function with all its replacements and I compare it to the original, they do not look exactly the same across the whole entire function, so that's going to be a no. Our function is not even. Let's go ahead and test for our function being odd, which means we have to replace both the x and the y with a negative x and a negative y. So I'm going to start by writing the original function. Instead of having the f of x, I'm going to replace it with a y. And then I'm going to go ahead and substitute in a negative y in for y and a negative x in for all the x's. And the right side's going to be like really easy to clean up because I already just figured that out over here. Oops. And so I already know what the right side's going to come out to be. Left side, just remove parentheses. Right side, we had negative 5x to the 7th plus 6x cubed plus 2x. And I see that my original function does not match my new one. And the signs are switched for that first term. So I'm going to pull that trick out of my sleeve and I'm going to divide straight across my entire function by -1. You can multiply by -1 as well. It does the same thing. Or you can just mental math this process and end up just switching all the signs. My negative y will become positive. My negative 5x to the 7th will become positive. My positive 6x cubed is going to be negative, and my positive 2x is going to be negative. And now we're ready to compare. And I look at my original and compare it to the new one, all cleaned up, and I see that I have a perfect match. So the answer is that yes, our function is odd. You can just write yes or no. You don't have to write it out the long way and say yes, your function is odd. That's a yes will do. Okay, let's just do one more problem and then that's it. We are going to be testing whether our function is even or whether our function is odd. So then I'm going to write down my original function and I'm going to replace f of x with y. I get y is equal to 5x to the 6th minus 3x squared minus 7. And when we check for y-axis symmetry, we're going to replace our x's with a negative x. And so I get y is equal to 5 times negative x to the 6th minus 3 times negative x squared minus 7. And then that cleans up to positive 5x to the 6th. This negative x squared is going to turn into positive x squared, and the positive x squared times negative 3 will be negative 3x squared again, and then we have minus 7, and I'm going to compare my new cleaned up version with the original, and I see they look like twins, so the answer is yes, that the function is even. Now, I don't even need to test for our function being odd, because if you remember back in the beginning of this set of examples, example 2 in the beginning, I said your function cannot be both even and odd. It's going to be even or odd or neither. So since I already found out that my function was even, you're done. There's nothing to check. I can go ahead and try to check the origin, but it's going to fail. So the answer to this is no, and you don't have to write this down, but I'm going to write it anyway. Our function cannot be both even and odd at the same time. One or the other or neither.